Welcome back to our channel Study with Adu. So now we are here with the part 2 of the derivation series for physics. So in first part we did derivation for the first 3 chapters. I'll be doing for the next 3 chapters. First we have moving charges and magnetism. Okay. First of all, what is Lorentz force? For Lorentz force, that is important chapter. That is Q into E plus B cross V. V cross B. This is Lorentz force, right? So from here, first derivation is magnetic force on a current carrying conductor. Magnetic force on a current carrying conductor. Okay. Yes. Look. I'm taking a conductor like this. Z axis, that is magnetic field. X axis, Y axis, length L, force. Look, always length, force and B will be perpendicular to each other. Okay. Now velocity of electron is drift velocity. You know that according to Lorentz force, F is equal to Q V cross B. Here V is what? Vd. That is QNA. Vd. You know that I equal to NAE Vd that we did in the last class. So Vd can be written as I by NAE. So I by NAE cross B. Q can be written as NAEL into I by NAE cross B. So NAE cancel. So IBL B cross L, right? So sin theta. This is the force. This is the derivation. Okay. Now motion in a magnetic field. You know that if there is only magnetic field, a charge will undergo in what path? Circular path. This is the idea. So what is the radius of that circular path? You know that a magnetic field is there. The charge is moving, radius r. You know that here force equal to QVB. Force can be written as what? Yes. So you know that here centripetal force should be equated with QVB. So mv square by r is equal to QVB. VV cancel. So therefore r equal to mv by QB. Important. Now time equal to 2 pi by omega. That is 2 pi VR. That's equal to 2 pi r by mv by qb. Sorry, I wrote it wrong. Sorry. Yeah, R is mv by qb. mv by qb by v. Right, velocity. V cancel. Therefore, 2 pi m by qb is equal to what? Is equal to the time period. 2 pi m by qb. Now rearrange this to find the other thing. Look, here we told that if a charge is entering perpendicular to the magnetic field, then this is the condition. If it is entering with an angle except some angle except 180, 0 and 90, then its path will be called as the cycloid path. It's like the thing will be having a rotational motion, as it will be having what? Front motion like this. So then R is given by mv sin theta, because only perpendicular component we will take. V is perpendicular component by qb, and time period is equal to what? 2 pi m by qb. Here the thing is that time period is independent of what? R or what? Velocity. So no problem. Now what is pitch? Pitch equal to tv cos theta. That is pitch means this distance. That is distance traveled for, if we starting from here, if one rotation complete, here one rotation is completed, what's the distance, linear distance traveled, is given by tv cos theta. That is t is 2 pi m by qb v cos theta. This is pitch. Okay, yes. Okay, so these are the important things in the chapter. Now we are going to listen about what? Biot's average law. What is Biot's average law? We'll just write that law directly. That's the thing we need. That is dB equal to mu 0 by 4 pi. What's the value of mu 0 by 4 pi? It is 10 raised to minus 7. Mu 0 by 4 pi I dl sin theta by r square. This is the what? Biot's average law. Okay. Yes. Now this law, please learn. Now we are going to derive the relation between epsilon 0 and mu naught. Okay, yes. So epsilon 0 mu 0. What is multiplication of epsilon 0 mu 0? This 4 pi epsilon 0 into what? Mu naught by 4 pi. If we multiply these things, two things also, we get the same, right? 4 by 4 pi cancels, right? Yeah. That is 1 by 9 into 10 raised to 9 into 10 raised to 7. This is equal to 1 by 3 into 10 raised to 8 whole square, right? That's equal to 1 by c square. So c equal to 1 by mu 0 by epsilon 0. Important. Okay, this is important. Now application of Biot's average law, one of the most important derivations from the chapter. That is magnetic field due to circular loop. Circular loop. Very important derivation. Very carefully you should hear to the thing. Why does look like this? It should be somewhat more beautiful. Yes. So this is the loop. Current is flowing here I. From the center I am taking a point P. That's R distance from the center of the loop. Now radius of the loop is a. I'm taking a dl division so I can integrate it easily. This distance I'm taking it as s. There's a phi angle. Now here also it is there, the same way I'm taking it. Now here db phi is there, db cos phi is there due to this. Okay, this is db. Due to this part, db is like this. Due to this part, db is like this. We are writing this is phi itself. This is db cos phi. Cos phi. So also phi itself. And here there is 2 db sin phi. Right? Yes. So these two components cancel. So at last, what? db is equal to what? Mu 0 by 4 pi I dl. Sin theta is what? 90 only. So no problem. I dl by s square. The distance between this and this, that is s square. So b can be written as what? Integral dv sin phi. Integral dv sin phi. What is sin phi? You know that this angle, sorry, one second. Yeah, this angle is phi. So sin phi is opposite side by hypotenuse, that is a by s. Substitute. That is b equal to mu 0 integral mu 0 by 4 pi I into dl by s square into a by s into a by s. Now take the constants outside, that is mu 0 by so very bad mu 0, it's very ununderstandable, looks like 5. Mu 0 by 4 pi into I dl. Dl, how can we take it outside left? I by I a constant, s also constant, s cube into dl integral is l. So we get this thing, that is b equal to mu 0 I a l by 4 pi s cube. Now the thing is that this s cube, how to write it? This s, how to write it as s? S square is equal to r square plus a square from the figure. Hypotenuse is equal to what? Opposite side by adjacent side, r square plus a square. Right? So s can be written as root r square plus a square. Whole cube. Right? This whole cube. So this is like s equal to 3 by 2. 3 by 2. So we'll substitute it here, that is r square plus a square raised to 3 by 2. So 3 by 2. Now what is this total length? L. L is the length, circumference of the loop, that is mu 0 I by 2 pi a by 4 pi r square plus a square raised to 3 by 2. Cut pi 2. Okay, therefore finally the answer is mu 0 I a by 2 r square plus a square raised to 3 by 2. Here there is here already we have an a, so a square will come here. Yes. So this is the equation. Simple but humble. Good equation, right? Yes. If the wire is having n turns, multiply it with the number of turns. Okay. Now accordingly change the formula. Accordingly for each case you will get the answer. This formula is important. Now Ampere circuit law. Ampere circuit law that is nothing, it is telling that B dot dl equal to mu 0 I. It states that integral of magnetic field around any closed circuit is equal to mu times the total current passing through the closed circuit. This thing. Now application straight conductor, magnetic field of a straight conductor. That is look, we are having a straight conductor, we are having a point P, and we have to find the current, the magnetic field. I is passing to it, the distance from the center is what, R. Then we can write B dot dl, that is equal to B dot dl means 2 pi R by R equal, so B dot 2 pi R equal to what, mu 0 into I, so B equal to mu 0 I by 2 pi R, This is the answer. One second, sorry for the distraction, I got a call. So mu 0 I by 2 pi R. So now we are having the next part, that is magnetic field of a solenoid. Yeah, next one is solenoid. Solenoid is very rarely asked for the exam because the derivation is not that very difficult. So it is like one second, sorry. Yes, so this is like a solenoid. This is the structure of a solenoid. Yes. Then you are going to prove it using Ampere's circuit law. One second. A, B, C and D. A, B, C, D. Okay. Yes. You know that integral B dot dl is equal to mu 0 I. Mu 0 I, total current. Yes. So integral B dot dl equal to integral B dot dl A to B plus integral B dot dl B to C plus integral B dot dl D to C, C to D plus integral D dot A, B dot dl D to A. Okay. One second. Therefore, you know that some of them cancel, only at last we get one thing, that is BL. Just BL. That's equal to mu 0 IN into L. B means what? Mu 0 I. B is what? Mu 0 INL. Therefore, B equal to mu 0 Ni. Okay, this is the derivation. It's very just learn this formula. This derivation is like very much what we can't understand what's the meaning of this derivation. It's like such a derivation, right? It is such a derivation. Okay, now next we have expression for this is not needed for a derivation. You can easily derive it, no needed. So next one is torque. Derivation for torque experienced by a current loop in a uniform magnetic field. You know that as torque experienced by a current dipole in electric field, like that a torque is experienced by current loop in a uniform magnetic field, and that's the principle of what? Yeah, galvanometer. So there's a north, there's a south. Why we are using this north-south magnet? Yeah, to produce a magnetic field. South, the magnetic field is there. Now I'm keeping a loop inside this. 1 second. Why this loop look artistic? A loop inside this. This length is B. This length is A. Okay. Current is flowing I, and this is the axis of rotation. So for this, tau equal to force into perpendicular distance. What is force? Force is IBB. That is perpendicular force. Should be like what? This and rotation is about, the force is about like this. What? Outside the plane. So IBL. So IBB. Yes. So force in a perpendicular distance, force is IBL sin theta. So IBB. Perpendicular distance is A. So that will be IB and BA. BA is area of the square loop. So IBA. I into A is MB. So this is F cross A. So F is sin theta. One second, not sin theta, sorry. F IBA, so MB. This is the answer. This is the answer. Okay. Yes. The thing is that here we kept this thing straight. Here we kept this thing. If we tilt this, if there is an angle between the axis and this, the magnetic field and the what? Square loop. What happens? North, south. Yes. This is B. This is A. Okay. Yes. So BA. So what I want to take is that I'm taking one arm and I'm just writing the equation. There is a force like this. The thing is like this. What? B is like this. A by 2 force. (90 minus theta). Okay. So what happens here? Here, perpendicular distance is A by 2 cos 90 minus theta plus A by 2 cos 90 plus 90 minus theta. That is A cos A sin theta. We get it totally as A sin theta. Now therefore tau equal to IAB sin theta. That's equal to tau equal to M cross B. M cross B. Okay. Yes. This is about it. Okay. Yes. Write it somewhat. This thing is important. This thing is important. Now derivation for the moving coil galvanometer. A moving coil galvanometer. First of all, we have a meter like this. Now we are having a circular loop. We are having north, south, north. This is a moving coil galvanometer's picture. You know that tau equal to NIAB sin theta. We proved it above. So that becomes tau is directly proportional to alpha. Tau is equal to K alpha. That is the angle. That's the angle. Okay. Yes. Now K alpha is equal to NIAB. Therefore, alpha equal to NIAB by K. I equal to K by NAB into alpha. That's equal to G into alpha. This thing is called the figure of merit. Now what is current sensitivity? Deflection per unit current. What is current sensitivity? Definition, one second. Let me check in the practical physics manual. The deflection induced in the coil of the galvanometer per unit passage of electric current. Current sensitivity. That's equal to IS. That's equal to alpha by I. That's equal to NAB by K. Now voltage sensitivity is equal to NAB by KR. Okay. So these are only the things that we should derive. Very simple. Only this much is there for what? Galvanometer. What is the principle? A current carrying coil placed in a magnetic field experiences a torque that magnitude of within depends on the magnitude of current. Just that is the principle. This thing is only important from here. Yes. So by this chapter, that is magnetism and matter, come to an end. Now we have the bar magnet chapter, but the thing is that in that chapter no derivation is there. No derivation is there. So the next chapter for our derivations will be, let me take it, that is electromagnetic induction. That's the next chapter. Okay. Electromagnetic induction. Electromagnetic induction, first of all, what is magnetic flux? It is BA cos theta. Same as what? Electric flux, that is EA cos theta. What is the EMF induced? It is minus d phi B by dt. These are the important formulas. Now first of all, we have the derivation for motional EMF. Motional EMF. That is we have a square plate. One second. Why this look like this? Okay, anyway. This look very untidy, my god. Something is there and this thing will move. This is moving with a velocity like this. Okay. Yes. This is x distance that's changing. This is the length of the road. E equal to d phi B by dt. So equal to d by dt of BA cos theta. What is the flux here? One second. Here something happened. BA cos theta. So yes. Okay. BA cos theta. So E is equal to d phi by dt. I told you. That is dBA cos theta by dt. Here A can be written as what? area. Cos theta is 0, no problem. A can be written as what? A can be written as, yes, length into breadth, Lx, right? So B will be coming out, L also will be coming out, so dx by dt. Yes, so hence we get EMF equal to BLV. BLV. Okay, this is the derivation for that. So therefore we got what? EMF as BLV. So what happened here? Sorry. Yes, next we have self-inductance. Self-induction. One second. Self-induction. Phi is directly proportional to I. You know that change in flux is directly proportional to I. So from that we get phi equal to Li. This is very important. L is self-inductance, I is current. EMF is equal to minus L into di by dt. Yes. Now derivation for what? Self-inductance of a solenoid. That's the main part here. You know that phi equal to Li, that is phi equal to NBA cos theta. These are two equations for phi. Now I will write total number of turn equal to N into L, that is what? Number of turns per unit length into the total length. Okay, for a what thing? B equal to mu 0 Ni. Here theta equal to 0 degrees, so phi can be written as mu 0 one second, not mu 0, one second, yeah, N A mu 0 Ni, right? Here N is the total number of turns, so change it to what? NL A mu 0 Ni. So therefore phi becomes what? Ln square A mu 0 I. This is phi. That's equal to Li equal to N square L A mu 0 I cancel. L equal to we'll write mu 0 first. Mu 0 N square LA. This is the self-inductance. Now if we need, we can substitute for N, that is total number by length. So that's equal to mu 0 N square into LA by L square. One L cancel. We get L equal to mu 0 total number of N square A by N L. This is the formula for a self-inductance. Okay. Yes. Now mutual inductance. So next part is mutual inductance. Mutual inductance means if there is a wire like this, another wire near to it, it's connected, galvanometer like this. This is having what? Current. If this is passing through this wire, there is a mutual inductance that is formed here. So due to the mutual inductance, this wire will have, this galvanometer will show deflection. That is about mutual inductance. For mutual inductance, it is the same. Phi equal to Mi, where M is the coefficient of mutual inductance. So like this, phi of the first one is equal to mutual inductance of 1, 2 into I of the 2. Sorry, something happened here. So, yeah. That is, it depends. Like phi 1, that is mutual, the flux in first one is equal to mutual 1, 2 into the current passing to 2. It's like that. Okay. Yes. So E1 is equal to minus M12 into di2 by dt. Now for solenoid derivation, look, first of all we are having a solenoid like this. We are having another solenoid like this. Then phi 1 equal to M12 into I2. So phi 1 is equal to NBA cos theta. Same thing, that is N1 A1 B of the second one, B2. So okay, so we equated M12 plus I2 is equal to, N can be written as N1 L into mu 0 N2 I2. Okay, therefore cut it. So therefore M12 is equal to N1 L N2 mu naught. So mutual inductance, so A we forgot, right? A is also here, A1. So M12 is equal to N1 N2 L mu naught A. So now the next one, if you find also, you will get the same, then you can equate it like that. Okay, now the next thing is the most important thing from this chapter, that is AC generator. AC generator. Yes, 1 second. Yes. Okay. And a generator is something that converts what mechanical energy to electrical energy. Principal electromagnetic induction. First of all, there will be a north. This thing is important. North and a south plate. South. In that there is a current carrying coil, a coil like this. 1, 2. AC EMF, alternating EMF. Now these two are connected by this, that is slip ring. This is called slip ring. Carbon brush. This is the structure. You know that E equal to minus d phi b by dt, d phi by dt. Phi equal to minus d by dt NBA cos theta. So that is equal to NBA. Theta equal to omega t. So NBA omega sin omega t. After we differentiating it, NBA omega sin of minus become plus. From here what we get NBA omega equal to V naught. Therefore epsilon is equal to epsilon naught. I will get the epsilon naught into sin omega t. This is about AC current. So this is the derivation of AC generator. Okay, so these are the things important from the chapter electromagnetic induction, derivations. Now next chapter is alternating current. 1 second. So next chapter is alternating current. Alternating current. For this chapter, this chapter is having a many derivations. Means, look, with the resistor, with the capacitor, with the inductor, with the resistor, capacitor, inductor, resistor, power, that, this, lot many, right? So first we will be learning with the what? AC and resistor. It's a simple one. That is having our AC voltage and we are connected it to a resistor of R, EMF E. You know that. If you apply Kirchhoff law, you get V naught sin omega t equal to IR. That is I into R. Therefore, I equal to V naught by R into sin omega t. This V naught by R, we note it as I naught. So, I equal to I naught sin omega t. Understood? Yes. Now, from here, if you apply it equally, okay. Now, we got. Now, what's the power? Power equal to I square R. That's equal to Im square, not Im, I'm using I naught, right? So I will use I naught itself. I naught square sin square omega t into R. Now the average value is equal to average value of I square R. That is average value of I naught square sin square omega t into R. The average value of this thing is I square R by I naught square into R by average of sin square omega t. That is equal to what? 1 by root 2 top. That is equal to, it's not 1 by root 2, 1 by 2 top, 1 by 2. So therefore power equal to I naught square R by 2. This is the average power. Okay. Yes. Okay. Now, what is IRMS? Really, IRMS equal to root of I square. That is equal to root of 1 by 2 Im square. That's very simple. Im by root 2. This is the IRMS value. VRMS value is also same. PRMS value is I square into R. We can get it easily. That is what? VRMS into IRMS into R. Very simple. Okay. Very simple. Now graph or phasor diagram. 1 second. Phasor diagram. What is the phasor diagram here? Some problem is happening. 1 second. Here, what's the phasor diagram? Here, velocity is going like this. Current is also in the same phase of velocity, so it will be going like this, but the amplitude will be less as V naught by Rs current. So this current is this other thing. Okay. Yes. That's the thing. Now AC voltage applied across inductor. What is this? Inductor. Yes. We are having an inductor, EL inductor. You know that V equal to Vm sin theta normal what that we got from AC. This thing is there. 1. Applying Kirchhoff law, you get something that V, that is this E, that is this V equal to L EMF L di by dt. L di by dt. That is di by dt equal to V by L. What is di? So take dt to the okay. One second. That is di is equal to Vm sin omega t by L into dt. Take it the other side, dt. Now integrate. I equal to yes, I equal to what we will get, 1 second. I equal to Vm by L is outside, integral sin omega t dt. So 1 by omega will come outside, then integral. So Vm by omega L into cos omega t. So minus will be here, minus cos omega t, cos omega t. This is the thing we found out. This is I. You know that sin omega t minus pi by 2 is equal to minus cos omega t. Okay, so we'll substitute there. I equal to Vm by omega L into sin omega t minus pi by 2. So it is lagging. Here current is lagging, pi by 2. Here Im can be written as, this minus will be going, right? So Vm by omega L, and this omega L is called what? Inductive reactance. That is XL. So therefore Im can be written as Vm by XL. So about it. Now when we draw the graph, current is lagging here, right? Current is lagging here. Current is lagging, pi by 2 behind this thing, pi by 2. Sorry, this touching is not correct. So we don't have that much amplitude. 1 second. We should draw everything properly, otherwise children will draw the same here. Less amplitude. Yeah, this will be current. This will be the current, this will be the voltage. So this is the diagram. I. Okay. Yes. Omega t. Yes. Now what is the instantaneous power? Power equal to IV. No need of I square, we will take IV. That's equal to Im sin omega t minus pi by 2. Vm sin omega t. You know that average of sin omega t. You know that, okay, take this. You know that, take minus Im Vm cos omega t sin omega t. We substitute this thing, we made it to minus cos omega t once again. So what we get? Minus Im Vm by 2 sin omega t. 2 sin 2 omega t, that is 2 sin theta cos theta equal to sin 2 theta. From there we derived this, took this. Now therefore power in inductive circuit is equal to I minus Im Vm by 2 into what? Average of sin 2 omega t. The problem is that average of sine, normal sine is 0. Therefore PL becomes what? 0. We got 0 as the power. 0 as the power. Now AC applied to AC voltage applied to a capacitor. Okay, we are applying AC voltage to a capacitor. What happens? Take a capacitor E, capacitor is C. Yes. V equal to Vm sin omega t. Normal equation. Voltage equation. Here's something, Vm sin omega t is equal to Q equal to CV. Q equal to CV. So V equal to Q by V. Equal to Q by V. Q by C. Sorry, Q by C. Q by C. Vm sin omega t is equal to Q by C. Right. Okay. So Q by C. Now I can be found out by dq by dt. That is what? From current electricity. Right. I is equal to dq by dt. So how we can write Q? We can write d by dt of CVm sin omega t. So therefore I is equal to CVm omega sin cos omega t. So from here I equal to Vm by 1 by omega c. I am taking it down. Cos omega t. Therefore Im is equal to Vm by 1 by omega c. 1 by omega c is called XC. That is capacitive reactance. Capacitive reactance. Okay. Yes. That's important. That is important. So this is for this thing. Here we got in terms of cos omega t. The problem is that we should change it to sine. So Vm by 1 XC into cos omega t, right? Positive. So sine omega t plus pi by 2. Sine omega t plus pi by 2. Sine omega t plus pi by 2. So therefore we got. So here current is what? Well, here voltage is lagging behind current for phasor diagram, right? What is happening here? Yeah, I is more. Voltage is less amplitude because it is Vm into omega c. So voltage is, current is like this. No, voltage, once again, voltage is like this. Okay, current is like this. Current. Okay. Yes. Now power is equal to, we have IA, we have a what? Power is very simple. It is very I into V. So I is what? Im cos omega t into Vm sin omega t. Therefore power is equal to Im Vm by 2 into sin 2 omega t. Anyway, sin 2 omega t will be 0 average. So P average is equal to 0. Here also it is giving us 0. Now phasors, no need of what? Many things and all. Okay. Now LCR circuit. That is what? Resistor, inductor, capacitor. Okay. So here V equal to LdI by dt plus Q by C plus IR. That's equal to V. That we wrote. So we can only have a proper phasor diagram solution here. So how to write a phasor diagram solution is a doubt of many kids in India. Okay. So how to write it? 1 second. So this is the axis, and what I'm going to do is that, look, V of resistor I, if current is like that, and this is will be V of inductor, because voltage is just what fast. Here voltage is lagging for VC. So this is what we are going to write on the figure A. Now what we will do? So generally we are going to write I equal to Im sin omega t plus phi as the what different phase. Okay. So from here we drew these three diagrams. Now what is the voltage due to the resistor? Very simple. Im into R. Voltage due to the capacitor. Im into capacitor reactance. What is this for ILM? That is for inductor. It is Im into inductive reactance. Okay, these three things we got. So equation 1, there was this equation 1 means that starting equation that we wrote, this thing. Yeah, this is the equation 1. This equation can be written as V equal to Im into R plus Im into Xc plus Im into XL. Right? This we can write these things this like this like this. That is V equal to Vc plus Vr plus Vm VL. You know that Vc and VL are in the opposite direction. So they can be combined into a single phasor which has a magnitude Vcm minus VL. Okay. Yes. That is, if I am drawing a new this thing. What? Phasor. Look. This is resistance Vrm, and this will be the new thing for what? VL plus Vc. This will be the phase difference phi omega t V. Okay, so we drew something like this. So therefore from figure B, what we can do is that we can take this RM and keep it like this. So we get a right angled triangle. From the right angled triangle, what I am going to write? V square is equal to Vrm square plus Vr plus VL whole square. Sorry, Vr plus Vr minus VL whole square. Show my what? Vc minus VL whole square. So here substitute it. Imr square plus Imxc minus Imxl whole square. Okay. Therefore V square equal to Im square into R square plus Xc minus XL whole square. Therefore Im is equal to Vm by root R square plus Xc minus XL whole square. And this down thing we can write this thing as V by Z, where Z is called the impedance of the circuit. So what is impedance? It is R square plus Xc minus XL whole square. That is impedance. This is impedance equal to R Xc minus XL. This is phi. Sorry. One second. The opposite way. Here Xc minus XL. Here phi. Therefore tan phi equal to Xc minus XL by R. So this is what derivation of LCR circuit. Now if XC is greater than XL, then phi is positive and the circuit is predominantly capacitive, that is current leads the voltage. And if XL is greater than XC, then the circuit is what? Yeah, it is called inductive in nature, that is current is lagging behind the voltage. In resonance condition, XC will be equal to XL. XC will be equal to XL. That is 1 by omega C equal to 1 omega into L. That is omega square equal to 1 by LC, or when omega becomes equal to 1 by root LC, at that time what happens? Here XC minus XL will be equal to 0, right? Hence what happens? Hence the circuit will become purely resistive, that is Im is equal to Vm by R. This is the new circuit, Vm by R. So here it is becoming what? Purely resistive, right? Yes. Now we are going to do the next derivation for power factor. That is V equal to Vm sin omega t in an AC circuit, and I equal to Im sin omega t plus phi depending. Im is equal to what? Vm by impedance, right? And phi equal to tan inverse XC minus XL by R. Instantaneous power equal to Vi. So power equal to what? Vm sin omega t into I, what is Im sin omega t, right? Im sin omega t plus depending on phi minus phi anything. So this thing we are getting. Now it will become Vm Im by 2 cos omega cos phi minus cos 2 omega t plus phi. Okay, 2 omega t plus phi, that is sin A sin B equal to what? Sin A sin B equal to what? Cos A minus B minus cos A plus B by 2. Cos A minus B by minus cos A plus B by 2. So from there average power is equal to what? Vm Im by 2 cos phi, that is Vm Im by 2 cos 2 omega t plus phi minus sorry, not equal to 2 omega t plus phi. What we get? Power is equal to Vm Im by 2 cos phi, Vm root 2 dot Im root 2 into cos phi power, or power is equal to Vrms into Irms into cos phi. This is the thing. What? Power. This is the thing on power. Okay, yes. Now we are having the last part, some things on transformers. A transformer is an electrical device for converting low voltage or high current to high voltage or low current and vice versa. There are two sets of coils, primary and secondary. Often primary coil is input coil and secondary coil is output coil. Principle is what? Mutual inductance. When alternating voltage is applied to primary, the resulting current produces an alternating magnetic flux which link with the secondary and induce an EMF in it. The value of this EMF depends on the number of turns in the secondary coil. Okay. So the figure. There are two types of transformer. There is shell type and core type. Shell type is like this. Like this. This is called shell type, and this is called what? Core type. Hello.
നീയല്ലേ ഒന്ന് പറഞ്ഞേ, വേറെ ആർക്കും അറിഞ്ഞില്ലേ? മറ്റേ ഗ്രൂപ്പ് ഫേസ്ബുക്കിലാ.
ഏത്?
അവൻ പോയാ?
അവൻ പോയി. അവന് this is called a what? Core type. Now working. E secondary is equal to what? Minus N of secondary into d phi primary by dt. Right? d phi primary by dt. So that is E primary equal to minus N primary into d phi secondary by dt. So EP is equal to VP. ES is equal to VS. So it can be written as Vs is equal to minus Ns d phi by dt. Vp is equal to minus Np d phi by dt. d phi by dt. Okay. So if we divide it, we get Ns by Vs by Vp is equal to Ns by Np. This is the first relation. This is called a transformation ratio. This is called transformation ratio or turns ratio. Turns ratio. It's called the turns ratio. Now, power input is equal to power output if there is no loss in power, 100% efficiency. So, Vp Ip is equal to Is Vs. Therefore, Vp by Vs is equal to Is by Ip. Yes. Is by Ip. This is equal to what? Ns by Np by Ns. Okay, perfect. Yes. Efficiency is equal to power output by power input. Okay. Yes. Now I am going to just tell about one thing. This very important question can be asked. Energy loss in transformation. Losses in transformation. Just learn some energy losses. Transformation is a transformer. One flux leakage. Two, resistance of the windings. Flux leakage, resistance of windings. Eddy currents. Hysteresis loss. This is not a theory, not a derivation, but these four things please learn and keep it up. So this is about these chapters. This chapter mainly RMS thing is asked, and rarely this transformer is also asked. Okay. Yes. So that's about these three chapters: magnetism, matter, EMI, and AC. Okay. Thank you.